So picture this. Your app goes viral. It's a huge success, but now it's breaking. Your single server just can't keep up with the flood of users and data. Well, that's exactly the problem we're going to tackle today with a really cool technique called MongoDB Sharding. It's how you scale your database way beyond the limits of just one machine.
Here's what we're going to cover. First, we'll look at why your database breaks in the first place. Then we'll jump into the solution, horizontal scaling. I'll show you exactly how sharding works, its three main parts, and we'll really dig into the most important piece, the shard key. After that, we'll weigh the pros and cons and finally help you figure out if you should even use sharding at all.
All right, let's dive right in. Imagine you've built this killer app, right? And it's a hit. But that success, well, it brings a whole new world of pain, all centered around the fact that you're running on just one server. Let's make this real. Imagine your photo sharing app just blows up overnight. We're talking millions of people signing up, uploading photos, scrolling like crazy. That super smooth app you built, it's starting to creak and groan under the pressure. So what's actually breaking behind the scenes? Okay, so you start hitting some major walls. First, the obvious one. Your dataset just gets too huge for a single machine's hard drive. Then you've got the write requests. I mean, think about 50,000 photos being uploaded every second. That's going to just crush your server. And the result? Queries grind to a halt. People trying to see their photos, they're just sitting there, waiting. And your users all over the world, they're getting that horrible lag. Your own success is literally killing your database.
So, what do? The answer isn't just buying a bigger, beefier server. It's about thinking differently with a smarter architecture. And that brings us to the solution, horizontal scaling. It's all about breaking free from the limits of just one machine.
And in the world of MongoDB, the main way we do this is with something called sharding. You know, at its heart, it's a really simple idea. You take one giant pile of data, you break it up into smaller, more manageable chunks, we call those shards, and then you spread them out across a bunch of different servers. And this is a really key difference in how you think about growth. You've got two main options. Vertical scaling is like trying to build one giant superhero server. You just keep cramming in more RAM, a faster CPU, but eventually you hit a hard limit. There's only so big one server can get. Horizontal scaling, which is what sharding is all about, is totally different. Instead of one superhero, you build a whole team. You just add more servers, and they all work together to share the load. Okay, so we get it. We need to split our data across a team of servers. But how does MongoDB actually pull this off? How does it keep everything organized? Well, it all comes down to three core components. I find it's easiest to think of it like a giant, super organized library. You've got your shards, those are the bookshelves, the things that actually hold all the data. Then you have the config servers. That's the library's map, or the old school card catalog. And finally, you have the mongos router, which is like the librarian at the front desk, telling everyone where to go. So first up, the shards. These are our book aisles. Each one is a server. Or, to be more precise, it's actually its own little team of servers called a replica set. And it's responsible for holding one chunk of your total data. So maybe shard A has all the user data for people with last names from A to M, and shard B has N through Z. And the really cool part is, because each shard is a replica set, if one of its servers fails, another one just steps in automatically. That's how you get that sweet, sweet high availability. All right, next are the config servers. You can really think of these as the brains of the whole operation. This is the card catalog of our library. Now, they don't store any of your actual app data. No user photos here. They store the metadata. They have the map that says, hey, that chunk of data you're looking for, it lives over on shard C. Without these guys, the whole system would be completely lost. And finally, we have the mongos router, our librarian at the front desk. And this is so important. Your application never talks to the individual shards. Nope. It just talks to this one router. The router then goes, let me check the map, the config servers, figures out exactly which shard has the data you need, and sends you requests to the right place. It hides all that crazy complexity from your app. So we have all these pieces, but how does the system actually decide what data goes on what shard? This leads us to, and I am not exaggerating here, the single most critical decision you will ever make when you set up sharding, and that is choosing your shard key. So what the heck is a shard key? It's just a field, or maybe a couple of fields, that exists in every single document you store. MongoDB looks at the value of that key to decide how to split up the data. It's the rulebook for where everything goes. If you get this right, you get a beautiful, fast, balanced system. But if you get it wrong, well, you've basically just built a really complicated and expensive single server.
The whole game here is to pick a key that spreads out not just your data, but also your workload nice and evenly. A classic bad idea is using a timestamp like created at. Think about it. Every new thing that happens now, so all your new writes just slam into one single shard, creating this massive bottleneck we call a hotspot. A way better choice? Something like a hashed user ID that ensures that every new user and all the stuff they do gets spread out randomly and evenly across all your shards. No traffic jams. And this chart, this just shows you the hotspot problem perfectly. Look at this. Shard A is getting absolutely hammered with 95% of the work, while shards B and C are just sitting there twiddling their thumbs. You've paid for 3 servers, but you're really only using 1. It totally defeats the entire point of doing this in the first place. Okay, now look at this. This is what we want. With a good shard key, like that hashed ID we talked about, the workload is spread almost perfectly across all 3 shards. Every server is pulling its weight. This is what a healthy, scalable system looks like. This is the dream.
So look, sharding is obviously super powerful, but that power doesn't come for free. It's a big architectural decision, and that means there are trade-offs. So let's be real about the power you get and the price you have to pay for it. Okay, on the pro side, you get pretty much infinite horizontal scalability. You need more power? Just add another shard. You also get crazy high write throughput because the work is spread out. High availability is baked right in, and your queries can get a lot faster. But the cons are pretty serious. We've talked about how hard it is to pick that perfect shard key. The complexity of running this whole thing goes way, way up. And some things, like trying to join data across different shards, can get really slow. And, of course, you're just plain going to need more servers. Which brings us to the big one. The most important question, really, was all this power, but also all this complexity. Should you actually use sharding? Figuring out when to make that jump is everything. And honestly, the short answer for most people is probably not. At least, not yet. Sharding is a solution for a very specific, very large-scale problem. As a rule of thumb, if your data is less than, say, 100 gigs, if you don't have a ton of write traffic, or if your app is simple enough that a single beefy replica set is doing just fine, then don't do it. Seriously, don't add complexity for no reason. And this is really the golden rule you should live by. Use sharding only when you hit the wall. Don't do it just because you think you might need it someday. That's called premature optimization, and it's a trap. Wait until you're actually feeling the pain, when your performance or your storage is maxed out. Solve the problem you have right now, not a problem you might have in the future. So, if you're going to remember one thing from all this, let it be this. Sharding gives you incredible, almost limitless performance and scale for huge write-heavy apps, but it comes at the cost of some serious complexity. So now you know how it all works. The components, why that shard key is so critical, and all the trade-offs. The question left for you isn't what is sharding anymore. It's, for your project, is all that complexity actually worth the power?